So here we have to give the definition of invertible function and some examples on finding the inverse of a function. So now, what is meant by invertible function? So an invertible function is defined as a function f which maps from the set x to the set y is defined to be invertible if there exists a function g which maps from y to x such that g of f that is equal to the identity function on the set x and f of g that is equal to I of y, which is the identity function on the set y. Now the function g is called the inverse of the function f. The function g is called the inverse of the function f. And so g is written as f inverse. So we can say that a function f is invertible, then so if a function f is invertible, then the function f should be bijective. And the function f should be bijective. It means what? It means that it should be 1, 1 and onto. 1, 1 and onto. And if the function f and conversely, we can also say conversely, if the function f is 1, 1 and onto, it means that if it is bijective, then we can say that it is invertible. And the function f is invertible. So, for example, you can say that you can give an example on it. Suppose it is told that let f be a function which maps from the set n to y, where n is the set of all natural numbers. So let f be a function which is defined as f of x equals to 4x plus 3, where y belongs to the set n, set of natural numbers, where y equals to 4x plus 3 for some x belongs to n. Show that the function f is invertible. So that f is invertible, and also find the inverse of f. Which is f inverse. So now if we take some element y, some arbitrary element y, which belongs to the set y, then it means that y will be equal to 4x plus 3. Which means that for some x belongs to n, x should be natural number, it is told here. So then we can say that x will be equal to y minus 3 by 4. So let g be a function which maps from y to n. G be a function which maps from y to n, such that g of y that will be equal to x, which is equal to g of x. G of y equal to x, so x will be equal to g of okay, g of y equal to x. So that will be equal to y minus 3 by 4. So therefore, we can say that g of x that will be equal to x minus 3 by 4. So therefore, now g of f of x that will be g of f of x, which will be equal to g of the function y is equal to f of x here. Y is equal to f of x, which is equal to 4x plus 3. So that will be g of 4x plus 3. So that will be 4x plus 3 minus 3 by 4. So here, so 3 and 3 will cancel. 4x by 4 is x. And also f of g of y. So that will be f of g of y. So that will be equal to f of g of y, which is y minus 3 by 4. So f of f of g of y so f of y that will be f of x, that is 4 into y minus 3 by 4 plus 3. So that will be y minus 3 plus 3, that is equal to y. Therefore, we can see that g of f of x that is equal to x, which is equal to I of n, and f of g of y that is equal to y, which is equal to I of y. So Iy is the identity element of the set y, and In is the identity element on the set n. So therefore, I can say that f, the function f is invertible function. F is invertible function, and so f inverse is g, which is equal to f inverse of x that is equal to g of x, which is equal to x minus 3 by 4. So this is the final answer. And then we can solve one more example, which is it is asked to show that if f is a function which maps from r minus 7 by 5 to r minus 3 by 5. So if this function f is defined by f of x equal to 3x plus 4 by 5x minus 7, and g is a function, which is r minus 3 by 5 to r minus 7 by 5 is defined by g of x equal to 7x plus 4 by 5x minus 3. Then we have to show that then f of g, that is equal to I of a, and g of f, that is equal to I of b, where the set A is r minus 3 by 5, and b equal to r minus 7 by 5. Where this IA of x, which is equal, that is equal to x, and for all x belongs to A, belongs to the set A, and IB of x, that is equal to x, for all x belongs to B, are called identity functions on the sets A and B. Are called identity functions on the sets A and B, respectively. So here we have g of f of x. That will be g of f of x, which is 3x plus 4 by 5x minus 7. So that will be equal to g of x, the g of x, that is equal to 7 into f of x plus 4 by 5 into f of x minus 3. So that will be 7 into 3x plus 4 by 5x minus 7 plus 4 divided by 5 into 3x plus 4 by 5x minus 7 minus 3. X minus 7 plus 3. Okay. So then here, put g of f of x. So that will be equal to 7 into this. 7 3s are 21. 21x plus 4s are 28. Plus this will be 4 5s are 20x. Minus 4 7s are 28. Divided by this will be 5 3s are 15. 15x plus 20 minus 15x plus 21. That is equal to 15x will cancel. So that will be this 28 and 28 will cancel. So this will be 41x by 41. So that is equal to x. So g of f of x, that is equal to I B. Since why here x should not be equal to 7 by 5. Here also you can write x, so x should not be equal to 7 by 5. So g of x equal to IB. And f of g of x. So that will be f of x is 3x plus 4 by 3g of x plus 4 by 5 of 5g of x minus 7. So g of x is 7x plus 4, 5x minus 3. 7x plus 4, 5x minus 3 plus 4y. This will be 5 into 7x plus 4, 5x minus 3 minus 7. So this will be equal to 3 7s are 21x plus 12 plus 4 5s are 20x minus 4 3s are 12 divided by 5 7s are 35x plus 5 4s are 20 minus 7 5s are 35x plus 21. So this will be 41x by 35x will cancel. This will be 1. So this is divided by 41. So this will be x, which is equal to IA of x. Since y here x should not be equal to 3 by 5. Here also this is IB of x. So now therefore we got the g of f of x that is equal to x, which is equal to IB of x. And for all x belongs to the set B, it means. And f of g of x that is also equal to x, which is equal to IA of x, which is for all x belongs to the set A. So hence proved. So hope you have understood how to find the identity, how to find the inverse of a function. So here you can see that f and g are inverse of each other. So since f of g of f and f of g is coming the identity function, so g equal to f inverse and also f equal to g inverse. So hope you have understood the concept. Thank you.